Last time we were looking at some new C# 12 features, which were collection expressions and the spread operator. And what I was going to look at this week was some performance issues that can come along with that and see how you can avoid those and actually see how Visual Studio is a bit misleading in one circumstance. What we're going to look at first is the idea of creating an empty array. Now the thing about an empty array, because arrays cannot have new values added to them, once you've got an empty array it is completely immutable, never going to change. Not true of something like an empty list, because even though it starts out empty, it could later on get bigger. But with an array, they're absolutely fixed. And so we can have some optimizations over that. And if we look at the code here, we can see we've actually got 4 ways of creating an empty array. And I've done each one of them twice. So we can do it with curly braces with nothing in them. That's an empty array. An array of length 0. We can use the array.empty, and we can use the new one in C# 12, the square brackets. And what I wanted to just show you here was what's happening in terms of memory allocation. Because if I just have a look at, say, curly1 equals curly2, remember we're doing reference comparison here, so we're going to see actually whether they're the same object. And I wanted to do that really for all 4 of these different ways of doing it. So we'll do it with a new 1 and a new 2. We'll do it with an empty 1 and an empty 2. And lastly with a square 1 and a square 2. And so if we run that, then we can see that the first 2 we're getting false and the second 2 we're getting true. And what that's telling us is that when we create an empty array using the empty curly braces, or when we do it using the new length 0, we're actually creating a new object every time. And so that's going to be inefficient, because we're going to keep on creating more and more memory that then has to be managed, deallocated, and garbage collected, and that sort of thing. Whereas when we do the array.empty, or indeed when we do the square brackets, and in fact the square brackets is just effectively calling the array.empty, the first time you call that, it creates one of them, but then it can reuse it any time you need an empty array with that particular element type int in this case. So we can actually demonstrate that, because if I just show you one more of these, if we compared square 1 with empty 1, then you can see we get another true on the end there, because they're actually just alternative ways of doing the same thing. And so in terms of efficiency, either of those last 2 are best, but in terms of neatness of code, I think the new square brackets one is best. And you can see we're getting messages on the first 3, so if we have a look here, we're being told avoid unnecessary 0 length allocations on those, and even on that one there, we're being told can be simplified because we could use the square bracket. So all of that is absolutely fine in terms of what Visual Studio is hinting that we do, and we can understand what's going on. This is actually related to a much older issue we have, the debate as to whether we should, on strings, if we want an empty string, so if I have this sEmpty 1, we can say string.empty and do that a couple of times. Or the alternative is we could do a string blank 1 and just set that to blank, and similarly with blank 2. And then we can compare those. Now the thing you've got to be careful of with strings, of course, is that the double equals operator for a string has been overloaded to do value comparison. We want to do reference comparison here, so we have to use the static method reference equals, so I can compare sEmpty 1 with sEmpty 2, and then also we'll do the same thing with blank 1 and blank 2, and indeed let's do the same thing again with an sEmpty 1 and the blank 2, so I can compare them both. And if we run that up, we're going to see all of those are coming out true. So in terms of performance, once again, we've got the trick that the double quotes with nothing in them is giving us the same predefined object as string.empty, and so there's not, again, a performance issue that we're creating lots and lots of these blank strings. We've just got the one. So that's all working fine. The other area I wanted to have a look at, though, is the spread operator. And with that, we have the ability that we can copy over an entire array. So something we could do is if we had, say, just an array of ints, call this A1 equals, and then remember we can initialize that 1, 2, 3, 4, 5, doesn't really matter much what. Then I could do something like this. I could say int array A2 equals, and then just use the ... and effectively copy that over. And so A2 is going to be a copy of A1. And we can demonstrate that because if I do something like, say, A2 element 2 equals 500, and then I output A1 element 2, then we're going to see that it's remained at 3. So that's a copy. That's not just sharing the same data. If I had just done this, then they'd both be 500, but we're making a copy. And so that seems like quite a good thing to do. But you remember again last time I mentioned the way that the spread operator works, certainly if we want to do it on our own collections, is it needs to be IEnumerable because that just enumerates through and copies each one over. So I've got loaded into this project already the .NET benchmark NuGet package, which we looked at in an earlier video. And so let's do some benchmarking of the various ways that we can copy one array into another. So what I'm going to do is add a class, and I'm simply going to call this tests. And so there we've got our test class. I need to make that public. And then onto that, I'm going to add the attribute memory diagnoser so that we can see what's happening in terms of memory. So pop that on there. And then I'm going to have, in here, we'll have a private read-only array that I'll call data. And this one I'm going to just initialize with 10,000 items. They're all going to be 0 by default, but just to have a nice big array so that we've got something to copy around and see what the performance is. Then I'm going to have a test. So this is going to return an array. Always a good idea to return something when you're doing benchmarking so that you don't have optimizations happening under the covers. And I'm going to call this with2array because this is going to do what I'd say is probably the traditional way of doing this, where we're going to say int array results equals, and then take that data and just call the toArray method on it. And then we'll return those results. And then I'll annotate that with the benchmark attribute. And also I'm going to have that as what's known as the baseline. So just we'll see percentages are going to be based on all of that. So that's the traditional way to do it. Then we'll copy that and do the same sort of thing. Don't want this one to be the baseline. And I'm going to do that with another method we have to do this, which is with copy2. And the way that one works is we'd have to say results equals new int array and then change that to data.length because we create the empty array and then we have to do this copy. So we're just going to say underscore data.copy2 and then the results, and then you can have an offset in there, but we're going to start at the beginning, so that's what we have there. And then finally we'll do it with the spread operator, and so we'll do that with spread. And in this case all we need to do is say results equals and then ... data. So that's doing the spread on our original data, and that should do the same thing. So those are our 3 ways of doing it that we're going to do the timing tests on. And then if we just comment that lot out, and then in here to run it, I just need to say benchmark runner dot run, and then generic for the class I just created, which was tests, and that should run our benchmarks. So let's now execute that. As ever, they take a little while to run, so I'll jump ahead and we'll see the results. And so now we've got the results, and if we just take a look at those, we can see that we've got the times there, but if we look at the ratios, the with2array and the copy2, similar sort of time, a bit faster on the copy2, but the important one, the with spread, is taking 3.5 times as long as the with2array and slightly more than that on the with copy2. So it's actually turning out to be rather inefficient. I put that memory diagnoser on there. Actually, we can see the memory for all 3 of these really is pretty much exactly the same. So that's not an issue, but clearly there is a performance issue. And as I say, you might have expected that because we saw that the spread operator is having to iterate through the collection. And we can take a look at another tool to see how that works, because there's a nice little tool online known as SharpLab. And so if we take a look at that, that allows us to put in some C# and actually see a number of levels of how it's processed. So we can look at the intermediate language, you can see there. You can look at the way that the C# has been broken down into more fundamental features, and you can even look at the JIT assembly, but I don't think you're going to see much from that. Thing to make sure is that we've got this C#12, so we can see that there. It's actually a slightly old build for C#12, but I think it's up to date enough that we can see what's going on. And so what I'm going to do is take the code that I had here in our tests, and let's put that into the Sharp lab. So I'll take that, pop it in there, and get rid of the benchmarking because we haven't got that package loaded and we don't need it. And also for that toArray, that's an extension method, so we're going to need to say using system.link, and then give that a second or two, and it should be able to work out what's going on. There we can see it, and we can see that if we look at something like the toArray, it just calls toArray, copy 2, but then the spread, that's actually looping through. Now, it's not actually using the IEnumerable. It's been smart enough to do an optimization that it knows that an array has square brackets, and therefore it can loop through like that. But it is still having to loop through those 10,000 items. If we look at it in intermediate language, it's not particularly clear what's going on, except thankfully for the comments. That's where the loop's happening in intermediate language. So again, we can see it's definitely looping through. But the C# is an easier one to look at, but that's obvious why it's slow. So actually, although in terms of syntax, ... the spread operator is really a neat way to go, and if you've just got very small amounts of data, might be worth going for. But if you've got large amounts of data, as we saw from those results there, it really is rather slowing things down. And then the really nasty bit about it, let's go back to Visual Studio and let's look at our error list. And it's telling us collection initialization can be simplified. And if we take a look at that, that toArray, which was not our absolute fastest, but it was certainly a lot faster than using the spread. But if we take the advice of Visual Studio, it turns that into the slower version. That is just awful to have Visual Studio suggesting a de-optimization, which absolutely it's neater in terms of syntax, but that is going to be slower code. And if you're doing this on big arrays, if you're doing it a lot, that's going to slow things down. So that was it. A couple of performance issues, one with creating empty arrays where everything really does fit together and make sense, and the advice that Visual Studio is giving us is both the neatest syntax and the most efficient. But here we've actually got the situation where the neatest syntax is not efficient at all, and so I suggest you should be very careful with it. Next time we're looking at some more C#12 new features, but I hope you enjoyed that. If you did, do click like, do subscribe, and I'll see you next time.